Hi everyone, and welcome back to the second part of the biological explanation of gender. So this second factor that we're now going to look at together is the role of hormones, or as you can see at the bottom, we can refer to those as neurochemicals as well. Okay, so if you see that word in an exam, the hormonal role played in gender, it just is talking about neurochemistry. So before we get going then, and remember you could get like a 1-mark question on this, we need to just clarify or define rather what hormones actually are. So we should already be familiar with this concept, but let's just refresh it together anyway. So, hormones are chemicals, as I've just said, that are released into the bloodstream at different points in our development, okay? And obviously, because they're released at different points in our development, they do have an impact on our gender behaviour, okay? So, when we're discussing the role of hormones or neurochemicals in relation to the development of our gender, we talk about two different aspects of hormones, okay? So we talk about the impact of hormones prenatally. So that's before you're born, okay? So these are things that happen what we call in utero. It's your brain developing, it's your reproductive organs developing, but all whilst you're still inside your mother's womb, okay? So this is before you've been born. And then obviously postnatal effects are after you've been born. Usually we're talking there about kind of like time surrounding puberty, okay, where we get a real fluctuation in our sex hormones or sex neurochemistry, okay. So what we're going to take a look at is several different neurochemicals, and the first one that we're going to take a look at together is testosterone. So as I've just said on the previous slide, we have to look at the role of testosterone at a prenatal level, so before the fetus is born, and then we're also going to look at what the impact is of testosterone around puberty. So prenatal exposure, and you already know this from what we've done on the SRY gene, but prenatal exposure to high levels of testosterone, which is classed as an androgen, affects genital formation. So it's not until a fetus receives the SRY gene or their chromosomes code for the SRY gene and they get the elevation of testosterone that the gonads actually turn into testes. So the main role of testosterone inside of the womb before the baby has been born is that creation of the male reproductive tissues of testes, okay? So as we know, all babies are female up until a certain point, and then only when the SRY gene is activated, if it's present, will the baby receive higher levels of androgens, and then their testes will develop, and then they'll go on to produce higher subsequent levels of testosterone. So it does contribute to the development of the testes, but also just testosterone generally speaking has an increased effect on muscle mass, bone mass, strength, and then obviously latterly body hair as well, okay? So that's all the prenatal effects of testosterone. If we have a look then at zipping it forward to postnatal effects of testosterone in the bloodstream, this tends to have an impact on the types of activities that boys, biological boys, obviously we're speaking about here, tend to engage with, all right? Now it does say at the bottom, and I want you to highlight this, we think that testosterone doesn't have that much of an impact on gender identity. So whilst it affects the types of play that little boys will engage in, obviously that doesn't necessarily have that much of a powerful effect on what they identify as at a later stage. But what we do know from research is that the testosterone in biological boys as small children has a definite effect on the type of play that they wish to engage with, all right? So you can see there that we've mentioned this in terms of child toy preferences, and this actually does have an effect on why biological boys tend to, but not always, prefer things like construction, kind of like cars and anything transport related. They tend to prefer that over playing with dolls and things like that, and that's where the estrogen comes in. So it does affect their child toy preferences. That then obviously can have an impact then going through into their choices as adult careers, because they've been playing with those kinds of toys from a young age, and they tend to obviously go for what we would class as more masculine careers, such as joinery, electricians, mechanics, all those kind of things. And the reason why is because testosterone has an impact on a specific set of abilities known as spatial abilities. So spatial abilities are the ability to kind of mentally create images and move them round in your head. So a lot of spatial awareness and spatial abilities are required in those kinds of careers, like mechanics and electronics, because it involves mentally transforming and rotating images to see how you would actually solve that problem. So if you kind of take that backwards, the spatial abilities have an impact on the adult careers, but those all stem from what the child is engaging with as a very, very young child. So like I say, it does tend to affect the types of toys that they play with, and then latterly the adult careers that they engage in, but it's less so of an effect on their gender identity. It's not the testosterone that makes them feel masculine, but it certainly shapes their brain and the types of play that they prefer to engage in, essentially, is what we're saying. Okay, so that's the role of testosterone. Now, we look at it prenatally and postnatally, but the third way in which we demonstrate the effect of testosterone is by looking at what we class as testosterone irregular conditions, okay? Now, there are two that you're going to look at, and there are already some actual notes in your booklet, all right, to begin with. But I'm going to send you some video links as well that I'd like you to watch, because it gives you some kind of extra details about these, okay? So the two conditions that you're going to look at are congenital adrenal hyperplasia. And you can see I've already got the notes from your booklet kind of screenshot here at the moment. But what I would like you to do is watch the video alongside this snippet of notes and make some extra annotations. So that's the first one, congenital adrenal hyperplasia. And then the second one, which we're going to look at, is complete androgen insensitivity syndrome. Okay, again, there's a video link to this. You've already got some basic notes, but I would like you to expand on those and make some extra annotations. So they're your two testosterone irregular syndromes that demonstrate the importance or the power of testosterone in young boys. Okay, so take a few moments now, break away from this video, go and watch the two links that I've sent to you, and just take those extra annotations for me. Okay, so now that we've got those notes taken down on the role of testosterone, we've just got a little bit of exam work built in here. So I'd like you to get this question in front of you. If you haven't been able to print it off, then obviously just doing this on a piece of paper. So all this question is, and it's only worth 2 marks, is to give 2 pieces of information from the scenario above that would suggest that Ben has got high levels of the sex hormone testosterone. So just have a read of that stimulus now, pause this video here and see what you would select to put into that answer. All right, so what 2 bits of evidence from that scenario do we have that Ben's got high levels of testosterone? Okay, so let's just have a look at the mark scheme and what's provided there as the responses suited to this scenario. So we've got Ben is a boy, all right, so that would be enough to get you a mark. So just simply being male means that you must have testosterone. You could also go for his age. So we know obviously the effects of testosterone are more powerful around about puberty. So you could get a mark for saying that he's 14. You could also get that mark for saying that he's probably going through puberty at that point in time. And then you could also refer to the fact that he's trying to assert his dominance. So dominance comes from having testosterone in the bloodstream. It's what we call an evolutionary hangover, which I've spoke to you about before. So you could get any of those, and it also says accept any other appropriate response. So if you think that there's something else that's relevant in there to testosterone, then you can credit that as well. Okay. So let's move away then from testosterone at this point, and now let's have a look at estrogen, which is almost, a lot of people class it as like the female equivalent of testosterone. So we're going to look at this both prenatally and postnatally, the same as what we did with testosterone. And again, prenatal exposure is more to do with the way that the brain is developing inside of the mother's womb, and it's responsible for kind of the reproductive organs developing as well. So prenatal exposure to really high levels of estrogen affects brain development by causing the brain to actually be smaller in size. Now, size of brain doesn't have any impact on kind of intelligence levels before you think that, but it does cause the average female brain to be smaller in size. But that goes for most of the organs in the female body. We are just typically that little bit smaller, and that might be the fact that we've got estrogen rather than testosterone. Okay, so that's one of the main roles prenatally of estrogen. The second one, which I've already referred to, is the regulation of your female reproductive system, so the generation of ovaries, okay, and then the elevation subsequently of estrogen. If we take a look at postnatal effects of estrogen, then this is more to do with our reproductive systems. So this is responsible for the production of what we call secondary sexual characteristics. So primary sexual characteristics are your reproductive organs. So in the case of biological females, that would be ovaries. Secondary sexual characteristics are all the things that develop as a result of that. So we've got breast tissue developing around about kind of early puberty, so 10, 11 years old in most females. And then obviously you get the development of the menstrual cycle. Now, whereas we said on the previous section, testosterone doesn't appear to have that much of an impact on a little boy's gender identity, for females, estrogen has a really powerful effect on their gender identity. And that's because the menstrual cycle is so heavily related to what a female identity is, okay? So if for example, a child is suffering from an estrogen abnormal disorder where they never have a period and they never develop their menstrual cycle, then that can cause obvious problems in the sense that they don't feel like a female, and that's where we can get an element of gender dysphoria coming through in early puberty, because they're not experiencing that thing that inherently makes the biological female experience that kind of gender identity of a female as well. Okay, so postnatally estrogen does play a really, really important role. And then finally, moving away from estrogen, we're going to have a look at oxytocin as well, because whereas with males, they predominantly just have testosterone, okay? There are lots of other androgens, but testosterone is the main one. With females, estrogen and oxytocin play a really important part in kind of our female identity. So, prenatal exposure to high levels of oxytocin in a female fetus compared to a male actually develops what we would class as maternal or feminine behaviours. That's why even in really, really young children, so as young as 2-3 years old, little female baby girls will engage in almost maternal play because of the levels of oxytocin that they've got in their brains and in their bloodstream. That is what generates the maternal instinct. So where little girls will start playing with those things really, really early, little boys tend not to, and we think it's mainly to do with the levels of this particular chemical. So the main role of oxytocin in actual fact is pain control during childbirth. So it's a very, very strong natural pain relief. So when you start experiencing your contractions going into labour, you'll have an elevation or a spike in oxytocin, which will allow you to manage your contractions. But that's only one aspect of it. It's its main one, but the other things that oxytocin allows you to do is breastfeed your child, okay, and then obviously the maternal bonding as well. High levels of oxytocin make a mother more vigilant, for example, when she's just given birth to the baby. So she will often hear responses in the child that the father won't be able to, and that's because of the oxytocin. So that's kind of before birth or during birth. After birth, oxytocin also affects how males and females respond to stress. So with females, because we've got high levels of oxytocin, we tend to show what we call a tend and befriend response, okay? And with males, they have more of an aggressive response, usually known as the fight or flight, because they have higher testosterone and less oxytocin. So oxytocin, as I've just said, is that real kind of maternal type of behaviours, that real maternal set of behaviours that make you inherently more caring. So that's where the tend and befriend response comes from. In times of stress, you want to look after each other, whereas with a male, they've got low oxytocin, so they just want to fight their way through it. So you get the fight and flight, okay? So what I'd like you to do now that we've covered those 3 neurochemicals is go back to your 9-mark plan now, okay? And I want you to do, again, the D, the E and the A section. However, whereas with the genetics half of it, I'd kind of given you a sample response, I want you to try and do this one on your own now so that I can just check this after Christmas and see whether or not that we've done this correctly. I have given you a bit of a prompt though that says you want to refer to testosterone and estrogen. Even though Sven is a biological male, we still want you talking about that breadth of neurochemicals. You could talk about him having a lack of estrogen if you wanted to, but you do certainly need to talk about both of those. All right. So that's part 2 on the role of neurochemistry. The third and final part of this is going to be the role of evolution and then a little bit of the evaluation content as well.